Imagine your family's on a trip driving late at night, excited to reach your dream vacation spot when all of a sudden the GPS on your phone gives out and you and your family are stuck in the middle of nowhere with no one to help you, all because of a short that occurred in a satellite hundreds of miles above you. Then, to make matters worse, you feel the brakes in your car slowly give out and fail, all because of another preventable short in your car's braking system. Although this is nearing a worst-case scenario, it is unfortunately something that isn't as unlikely as you may think. Tin whiskers are the problem, and their growth can cause shorts in electrical circuits. Being able to mitigate its effects can save potential losses in both safety and finance for those affected. So, sponsored by NASA, MDA, and NAVSEA, our team got to work brainstorming and doing all the research we could. To solve this problem, we interviewed over 50 specialists with various backgrounds from our sponsors' organizations and other industries, and we read numerous pieces of literature in the process. Wanting to find the best possible solution to tin whiskers, we first look at how we can prevent growth altogether. But after much discussion, we found that we may not be the best suited to crack the code to this 50-year problem. Being our stubborn selves, it wasn't the easiest change to make, but we then realized there is another possible solution to work towards that may be just as effective, so we then made a pivot. With the guidance of our sponsors, we decided to predict the probability of tin whiskers falling and bridging and causing a short instead of the original formation of tin whiskers. We were able to create a tool to help predict this probability by using a Monte Carlo simulation as well as degradation mechanisms, then combining the two to produce the final POF of the problem and merge with consequence levels created by the user to come up with the final risk. This final and complete tool uses a very simple user interface comprised of units with clear instructions and labeled outputs. The result of the tool are then filled into the color-coded risk matrices that show clearly if the system is at risk, and the if and when it needs to be fixed, thus making a mission assurance team report very easy. These easy-to-read matrices show the full result of what you need to know, and then can be properly documented and shared with mission assurance team to create the best course of action.